Okay, so looking at this, it already says there's one solution. I'd prefer to kind of ignore that because you won't always be told that there's one solution. So you have this triangle with angle A is 115, side A is 20, and side B is 11. We want to solve it and round the answers. So once again, we are going to be using law of sines, and we're first going to need to determine what type of triangle it is first. So let's go ahead and draw a sketch. That's going to help at least me and you guys who are visual learners see what we're doing. So if A is 115 degrees, I'm going to say we're looking at something like this. That's A. And our opposite of A, let me draw this out more, is 20. That's what they say. Our side length of A is 20. And then we'll call B over here and C over here, and we'll say that this is 11. So they want us to solve everything. If you can see what we're at, obviously I drew it, but if you look on the notes and in the last slide, we had the case where A is obtuse. Since it is obtuse, there are two cases only. If our side length A is greater than our side length B, then it works and we can just go ahead and use the law of sines. If it's not, then there's no triangle. Looking at this, 20 is greater than 11. Definitely. So we're going to go ahead and use the law of sines. That means we've got sine 115 degrees over its side length of 20 equals sine of our B over the side length 11. Now this one is different because you're going to have to use your calculator to solve for sine B, and I'm going to show you guys how to do that. But first up, let's go ahead, cross multiply. That's 11 times sine 115 equals sine B times 20. So we're going to divide by 20. So once you plug it into the calculator, you'll get sine B to equal 0.498-ish. But we need our angle B, not sine B. So what you're going to do is you're going to go ahead on your calculator and you're going to look for the button that looks like that. That is the inverse. You are going to take the inverse of both sides, which in your calculator, all you're going to type in is sine -1, that button. I believe if you hit second and then sine, that's typically where it's at. Don't take my word for it. Definitely find it for yourself. And then you just put 0.498. The reason why this works is because sine and the inverse of sine cancel each other out, and then you're left with B. So once you do that, B will equal, rounded, will equal 29.9 degrees. Please try that in your calculator right now and make sure you get 29.9 degrees. Don't move on until you have made sure you do this. Okay, so now we know our angle B, 29.9. We can go ahead and find our angle C by using our triangle angle sum theorem. All that is taking 180 and subtracting our angle values by it. So minus 115 minus 29.9, that gives us 35.1 degrees, and that is big C. We'll call that our, let me make that smaller. This is not working, hold on. Equals big C. All right, and it's in degrees. There we go. So now that we have that, we can go ahead and use a law of sines once again and solve for our side C. That's the last thing we are missing. So setting it up, sine 115 over 20, that's what we had. And then now we have sine of 35.1 degrees over that c that we're looking for. That's our missing piece. It's little c. So c times sine 115 equals 20 sine 35.1 divide by sine 115. And c equals, or approximately equals, 12.7 units. And those are our three missing pieces. Now on the test, I would have you like, I'm going to give you like a space to label them. Sorry, that is my chair. I'd give you guys a space to label, and I'll say like find C, find B, find A. And so I can find the work within your work, but I will want you to label it outside on your test. Hopefully that makes sense. All right, this is our first case. We've got 2 more problems that we're going to do, and they're going to be 2 different cases after that. Go ahead and we're going to head into the next video.